So in this video, we're going to look at direct and inverse proportions. This video is split into a few parts. So first, we're going to start by looking at, well, how exactly do you write something like this using a constant? So x is directly proportional to x and x is inversely proportional to x. Then we're going to look at, well, how do you tackle questions like this, where you're asked to find a formula for y in terms of x for direct proportions and inverse proportions. And then we're going to look at, well, how do you find the value of y in a question like this with direct and inverse proportions? And then we're going to look at, well, how can we use a table to answer these type of questions? And then finally, we're going to look at compounded proportions. So in this case, we have both inverse proportions and direct proportions to find a formula for y. And as always, we're going to wrap up by looking at two actual exam questions, which you build up to. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause, and I've got the example on the right, which is you do. So what exactly is the question saying? Write an equation including the constant k of proportionality. So we have y is directly proportional to x. We can write this as y is directly proportional to x. Now that symbol there is the constant of proportionality. That's what we call that. And since the question asked us to write an equation has an equal sign, so we can write this as an equation by replacing that equality, the proportionality sign, with an equals and introducing a constant k for proportionality. So all we've done here is we've replaced the constant with an equal sign and a k. Okay, so the k is the constant for proportionality. So looking at the next example, it says y is directly proportional to the square of x. So we're going to say y is directly proportional, that's what that sign means there, to the square of x. So that's going to be x squared. And now to write that as an equation, we're just going to swap that sign out for an equals and a constant k for proportionality, and there's that. And finally, looking at the last one, it says a is directly proportional to the square root of b. So that's the expression, and to write that as an equation, we're going to replace that sign with an equals and a k, which is the constant for proportionality, and the square root b. Everything else stays the same. So press pause and have a go at the examples on the right. So hopefully you had a go at these. So the first one becomes y is directly proportional to 3x, which we can then write as an equation as y is equal to k times 3x. So you could have also written this as 3kx. Next one, y is directly proportional to the cube of x. So that's going to be x cubed. We can then replace the proportionality sign with an equals k x cubed. And then finally, we have t is directly proportional to the cube root of r. So the cube root of r. And again, replace that with an equal sign and a k. And the k is the constant for proportionality. Moving on, we're now looking at inverse proportion. So remember, direct proportion was y is directly proportional to x, is written like that. And when you have inverse, you write it as 1 over x. Okay, so in this case, this is going to become, we're just going to replace the proportionality sign with an equal, as we've always done, and we're going to write k, and the rest is the same. So again, with the next one, we have y is inversely proportional to the square of x. So we write that, and then we replace the sign with an equals and a k. And finally, a is inversely proportional to the cube root of b. So it's just 1 over when you're doing inverse. And then finally, as an equation, that becomes that. Again, hopefully you've pressed pause and had a go at the examples on the right. So we're going to write y is inversely proportional to 3x. And that becomes y is equal to k over 3x. And then we have t is inversely proportional to the cube of p. And that becomes t is equal to k over p cubed. And finally, e is inversely proportional to the square root of f. And that becomes e is equal to k over f. So here's some practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers, mark your work. So moving on, we're now going to look at questions like this. So here we've been given that y is directly proportional to x on the first line, so we can straight away see right that. Then we're told that y is equal to 10 when x is 2. Find a formula for y in terms of x. So we're going to carry on as we've done at the start. So first we're going to write an equation for this. So an equation, we're just going to replace the proportionality symbol with an equals, a constant k and x. We're now going to substitute the values for x and y in, and I'm just going to highlight them on this example. So that's y from there, and that is going to be k coming in from there. So that is going to be 10 is equal to k times 2, and we can now rearrange that to make k the subject. So if we divide each side by 2, we end up with k is 10 over 2, which can be simplified to 5. And now we can substitute that into this formula, and we can write this as y is equal to 5x. So that is the answer to the question. So it said find a formula for y in terms of x, and that's a formula for y, which means y is equal to something, in terms of x, which means there's an x on this side. So hopefully you've pressed pause and had a go at the example on the right. So straight away I can see it says y is directly proportional to 2x. It's the expression. To write that as a formula, that can be written as 2kx. And then we're going to substitute the values in. So that's going to be 18 is equal to 2 times k times x, which is 3. And that's going to be 18 is, we can tidy that up. 3 times 2 is 6. So we can just say that's 6k. Divide each side by 6. And we can have k is equal to 18 divided by 6, which is equal to 3. And now we can substitute that up in here to get our answer. So that's going to be y is equal to 2 times k, which we now know is 3 times x. And that is going to be y is equal to 6x is our answer. Moving on. So now we have a square. So it says y is directly proportional to the square of x. So we can write that as y is equal to kx squared. And then that, now we're going to substitute the values in. So that's going to be 100 is equal to k 5 squared. We can rearrange that for x. So that's going to be 100 over 5 squared, which is 100. 5 squared is 25, and that then becomes 4. Now we know what k is, so you can substitute it into this formula here, and that then gives us y is equal to 4x squared, and that is the answer to the question. So that is a formula for y in terms of x. So again, hopefully you've pressed pause now to go at this. E is directly proportional to the square of t, and then writing that as an equation and substituting the values in and rearranging that for k. And 4 squared is 16, and that becomes 2 for k. And now we can go back up to our equation there, and we can substitute the value for k in. And that is your answer. And now looking at square roots. So we have p is directly proportional to the square root of q. So again, write the equation out as we've done before. Replace the sign with an equals and a k. Substitute the values in. Rearrange this for k. And now sub the value for k back in, and that is your answer. That is a formula for p in terms of q. And with this one, again, replace that symbol with a k and an equals. Substitute the values in. Rearrange that for k. And substitute k into here. And that is your answer. So here's some practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers, mark your work. And now we're going to look at inverse proportion. So you've been asked to find a formula again, but this time we're told that y is inversely proportional to x. We're going to write that as an equation, so replace the sign with an equals and the k in full. And there's the x. Now sub in y and x. And rearrange that. So move the 2 over, that's 10 times 2, which is 20. Now we know what k is. We can just substitute that into this formula and we have our answer. So y is equal to 20 over x. And that is a formula for y in terms of x. So here we have A is inversely proportional to 4B. Substitute the values in, and that becomes K is equal to 3 times 8. And that's that. And now just sub the value of K into here, and you have your answer. So that is 24 over 4B. In fact, that can be simplified, so we can write that as 6BA is equal to 6B. So we have P is inversely proportional to the square of Q of inverse. So now P is equal to K over root Q, and then P is 9 is equal to K over root Q, which is to the, oh sorry, it says the square. So that'll be Q squared. So I was just about to say you can't square root of 3, so that's going to be 3 squared. So that will be K is equal to 9 times 9, which is equal to 81. And then the answer becomes P is equal to 81 over Q squared. And then looking on the right side, we have E is inversely proportional to the square of T. So that's E is equal to K over T squared. And sub the values into is equal to K over 4 squared. K is equal to 16 times 2, which is equal to 32. And that becomes E is equal to 32 over T squared. And here we have H is inversely proportional to the square root of T. And again, same as usual, put the equals in K, square root T, sub the values in. And square root of 5 just becomes a 5, so that's going to give us 25 there. And then the answer is going to be 25 over root T. And K is 3 times, and square root of 36 is 6, so that then becomes 18. Sub the K in there. Here's some practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers. And now we are looking for, so now the question is saying find the value of y when x is 6. So before it was asking you to find the formula, but in order to do that, you will still need to find the formula. So we are going to start in a similar manner. So we have y is directly proportional to x. So write that as an equation. Find the value of k by substituting the values in. Now you know what k is. You can write this equation as y is equal to 10x. Now, if you read the question, it says find the value of y when x is 6. So y is equal to 10 times x, which is 6, and that is 60. So again, hopefully you've pressed pause and undergrad the example on the right. So reading the first line, it says A is directly proportional to B. I'm going to write that as an equation, replace that symbol with an equals and a k, substitute the values in for A and B to get the value of k. Rearrange that. Now that I know what k is, I can substitute that into this. A is equal to 4b. And now the question says find the value of a when b is 3. So a is equal to 4 times, put b into there, and that value is 12. Moving on. So again, we've been asked to find the value of m when n is 2. So start with what the question says. M is directly proportional to the cube of n. Now substitute the values in to get the value of k. Now we have the value of k. We can say that m is equal to, oh no, you know what k is? 3n cubed. Now the question is saying find the value of m. So m is equal to, when n is 2, so that'll be 3 times 2 cubed, which is 3 times 8, which is 24. So again, hopefully you've pressed pause and had a go at this. Now let's sub the values in. And now we know what k is, we can put it in there. Reading the question, so it says find the value of h when d is 36. So that is going to be 10 times 6, which is 60. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers, mark your work. So now we have the inverse proportion. So it says b is inversely proportional to the cube of w. Writing that by replacing the symbol with an equal sign and the constant k. And now subbing the values in. So b is 10, w is 5. So that's going to be k is equal to 10 times 5 cubed, which is 125. That gives me 1250. And now if I sub that into here, we can say that b is equal to 1250. Divide that by w cubed. And so now the question is saying find the value of b when w is 10. So b is equal to 1250 over 10 cubed, which is 1250 over 1000. We can cancel the 2 zeros out, and then we can leave it at that one. Actually, it's divisible by the 5 times table, or we can just go ahead and just write the decimal out as 1.25. So h is inversely proportional to the square root of t. So it's inversely proportional, so it'll be 1 over. Again, we're going to replace that with the equal sign. Sub the values in. And that is going to be 50 times 5, which is 250. And we can put that into here. And the question says, find the value of h when t is 36. So now when t is 36, it's going to become root 36, which then becomes 6. So we now have 250, divide that by 6, and that can be simplified to 125 over 3. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers, mark your work. And now we're looking at, well, sometimes a question can ask you something like find the negative value of x. And what exactly does find the negative value mean? So if you work through this question, it says that y is directly proportional to the square of x. Writing that as an equation becomes this. We've done that many times. And now subbing the values in, that's 50 is equal to k 5 squared, which is 25. We've just done something similar. So that's going to be 25 there, which then becomes 2, which means I can write this as y is equal to 2x squared. Now it says find the negative value of x when y is 18. So let's put y is 18 into this. So that then becomes 18 is equal to 2x squared. Now divide each side by 2, that means 9 is equal to x squared. And now if I square root each side, I get x is equal to plus minus 3. And now it just wants the negative value, so we're going to say x is equal to minus 3 is our answer. Now, the reason the question saying find the negative value is because in order to get 9, you could do 3 times 3, which gets you 9, but you could also do minus 3 times minus 3, and that also gets you 9. So whenever you square root a number, you have 2 possible answers. It could be a positive or a negative. So looking at the one on the right, so it says m is directly proportional to the cube of n. So we can, again, go ahead and solve this. And m is 24, k, and n, that's going to be cubed there. So that's going to be 24 divided by 8 is equal to k. which is 3. You can sub that into here, so m is equal to 3n cubed. Now, so you find the negative value of n when m is 81. So we'll sub that in, m is 81 is equal to 3n cubed. Now, if you do 81 divided by 3, you get 27 is equal to n cubed. Now, if you cube root each side, so that will be n is equal to the cube root of 27. And the answer there is, again, you can have two possible answers. It can be 3 or minus 3. But in this case, the question is only asking us for the negative value. So we're just going to write minus 3. And again, you can check that on your calculator, because if you did 3 times 3 times 3, and then if you did 3 times minus 3 times minus 3 times minus 3, you'd get the exact same answer, which is 27. So looking at this one, in this case, we've been given a table. So it says y is directly proportional to x straight away is what we're told. We can write that as an equation like this. And it says find an equation for y in terms of x. Now we have got that written, y is equal to kx, but we need to find out what k is. Now in order to find out what k is, we need to substitute some values in. So we're just going to pick any one of these. So I'm just going to pick that one there. So in this case, y is 20 and x is 2. Which means that k is 10. That means that the answer to this question is y is equal to 10x. So that is the equation for y in terms of x. And again, it's the exact same thing on the right. So it's saying y is inversely proportional to x. So y is equal to k over x. And we need to just pick a point. Again, pick something simple. Don't try to pick that one. That looks too difficult to sub in. Just pick something nice and easy like that one there. So y is 4, x is 1, so we can see straight away that k is just 4, so that becomes y is equal to 4 over x. So now with this, these are the slightly trickier questions where you have both inverse and direct proportion within one question, but we'll tackle each part of the question one by one. So first we'll focus on this part of the question and then this part. So we're told that y is inversely proportional to d, and we're told the value of y and d, and then we're told that d is directly proportional to x, and we're told the value of d and x, and then it says find a formula for y in terms of x. So let's just start with the first bit. So if we just start off with this here, so we can say that y is inversely proportional to d. We can then say that y is equal to k over d. We can now sub in y and d, which means that k is equal to 40, which means the formula can be written as, in fact, I'll just use blue, y is equal to 40 over d. Okay, so that's one formula that we've gotten. Now let's look at the second part where it says d is directly proportional to x. Now let's sub in the value for d and x, and we know that k is 2. So we can write this one, we can just sub k in, so we can say d is equal to 2x. Now it says find a formula for y in terms of x. So when it says find a formula for y in terms of x, it's saying y is equal to something that contains x. So we can see that this formula up here is already written in that form. So if you take that formula up there, and I'll write that here, so I'm just going to write that exact same thing here, y is equal to 40 over d. Now, at the minute, we do have a formula for y, but it's not in terms of x. What do we know about this d here? We know that we found out what d is there. So if I sub that into there, just show you what happens then. So y is equal to 40, and for d, I'm going to substitute that in. That's 2x. And that is a formula for y in terms of x. Now, we can simplify that, so that can be written as y is 20 over x. So hopefully you've pressed pause and had a go at the example on the right. So it says h is inversely proportional to p. I should really be using the other color. I should probably start on the top left too, because I'll need the space. So h is inversely proportional to p. H is equal to k over p. H, k, p, k is 6, 12, 18, 24. Now I can write this as h is equal to 24 over p. And now looking at, so that's done. Let's look at this now. So it's saying P is directly proportional to N. Let's sub the values in. So K is equal to 8. So it says find. So, and then we can just put that into here. So that's going to be P is equal to 8N. So now it says find the formula for H in terms of N. So we know the formula for H at the moment is H is equal to 24 over P. But it's not in terms of N, but we can substitute this value of P into there. And that becomes H is 24 over 8N. And again, that can be simplified to 3 over N. So looking at the next one, so we have R is directly proportional to T. And again, I should probably use the other color. Substitute the values in. So we know K is 5. Substitute K into there. And now look at this one down here. So that one's done. So T is inversely proportional to S. And sub that value into here. So that's going to be T is equal to 6 over S. Question is saying find a formula for R in terms of S. So the current formula for R that we found is R is equal to 5T. It's not in terms of S, so we can substitute T into here. And that is going to become 5 times 6 over S, which can be written as 30 over S. So that is your final answer. So again, hopefully you've pressed pause and got the example on the right. So it's saying E is directly proportional to F. So you can say E is equal to KF sub E, so that's 15, is equal to K times 3. So K is equal to 5. And now we can write that up here. So that is E is equal to 5F. And now looking at this one here, we have 5 is inversely proportional to Q. Let's say F is equal to K over Q. And then F is 2, we have K, and then we have Q, which is 6. K is equal to 12. We can sub that into here, so that is going to be F is equal to 12 over Q. Now it's saying find a formula for E in terms of Q, so E is 5F, but it wants it in terms of Q, so we're going to have to sub that F into that. So that is E is 5 times 12 over Q, which can be written as 60 over Q. I'm going to skip this one because it's similar to the last one. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. And now we're going to look at 2 exam questions. So feel free to press pause and have a go at this first. So it says H is inversely proportional to P. P is directly proportional to root T. Okay. Given this, find that. Okay, so if you start off by looking at this one here, so that is H is inversely proportional to P. Okay, so H is equal to K over P. Do I know what H is? Given that H is 10 and T is that when P is 6, so H is 10, P is 6, so I know that here K is 60. That means I can write this as H is 60 over P. Perfect. So now that I've looked at that, I'm now going to look at this one. P is directly proportional to root T. P is equal to K root T. Now substitute P in, which is 6. K root 144. And that means K is equal to 6 over root 144, which becomes 12. K is equal to a half. And if I sub that into here, I can say that P is equal to 1 over 2 root T. Now it says find a formula for H in terms of T. So the current formula for H that we have is that one there. So currently that formula is saying that H is equal to 60 over P. It wants it in terms of T, so we can substitute this P into there. So that's going to be H is equal to 60 over root T over 2. And then we can rewrite that as 120 over root T. So that is your answer there. And the next one, so we have K is directly proportional to the square of Y. So x is directly proportional to the square root of y. So what is the value of x? So when x is 32, z is 2. So there's not enough in here for me to figure out y, because although in the question they've told me z and x, they haven't told me what y is. So we'll leave that there. Let's look at the next one. So that says y is directly proportional to the cube of z. So y is equal to kz cubed. And again, I know what z is here, but I don't know what y is. Okay. Find a formula for x in terms of z. So what I'll do here is I'll add a little subscript so it's clear what constant refers to what. So I'll put a little y there, and I'll put a little x. And actually that could be confusing. What I'll do is I'll put a number 1 there and a number 2 there, just so it's clear what's coming from where. So someone says, what's the constant for y? It's k with a little 2. So find the formula for x in terms of z. So that draws my attention right there, because that's in terms of x. So I can say x is equal to the constant for k, but it says in terms of z. So we want to substitute the y value from here into there. So if I do that, that becomes x is equal to k, and then keep the squared, put y into there, so that'll be k to z cubed. And if I expand that out, that's k for x to k squared for y, and then the z to the power of 6 due to indices. And I'm left with that. Now, these two are both constants. So if I just put a little border around that, these two are just constants. And now if you look at the question, what have they told us? Z and x. Now if I substitute z and x into this equation, I have 32 is equal to some constant. I'm just going to draw the box. Some constant k. And then z to the power of 6. So that's going to be 2 to the power of 6. Now if you do 2 to the power of 6, you get 64. So I can just replace this with 64. And we can just say that 32 divided by 64 is equal to the constant, which is the blue box. So we're saying that the value of the blue box essentially is a half. So it's 1 over 2 is equal to blue box. And remember what the blue box is, just this whole constant. So now that we've got that, we can rewrite this, and we can say that formula for x in terms of z is going to be x is equal to a half z to the power of 6. So if you found this really useful, I've got loads of other content like this on my YouTube channel. Do check it out, and as always, I'll catch you in the next one.